All right, fifth graders. Some weird things going on with this computer lately, but let's see if we can't get this going. I'm going to share my screen with you as always. We are working on Module 10, Lesson 4, which is representing and finding equal size parts. So a little bit different. We've now gone from dividing a unit fraction by a whole number to a whole number by a unit fraction. So I always like the way that looks for you. Maybe, oh, if it would stay, that would be good. All right, I think that's it. All right, fingers crossed it stays and doesn't fall. So here we go. The visual model is representing 3 divided by 1/6. Write the division equation that represents the visual model. So we have 3 whole parts. Each part is divided into 6. So we're dividing it by 1/6, which would give us how many total parts? 18 would be our answer. And you can check, you can do our keep, change, flip. Yeah, that's the action. Everybody's going to know how we're dividing fractions. So you can also do that to double check yourself. We did a keep for our whole number. We changed dividing to multiplying. When I flip 1/6, it becomes the reciprocal, 6 over 1. If there's a 100, it's a whole number, so we're going to just put a 6. Next, it's asking us to draw the visual model to represent the expression and then find the quotient. So we're starting off with 2 whole bar models. They're being divided into fifths or 1/5. So each of these divided by 1/5. How many parts do we have? We have 10 parts. Here, I have 4 parts, 4 whole parts, each of them divided by 1/4. So each of them are divided into fourths. How many total parts do we have? Ooh, this one, I know, doesn't look great. That's all right. We know what it is, right? How many total parts? 16 total parts. And again, for example, keep, change, flip gives us 16. Look how this one goes with your science. Earth and Mars orbit the sun. Each time Earth makes one complete orbit, Mars makes about half of its orbit. How many orbits does Earth make around the sun in the time it takes Mars to complete 6 orbits? So if each time the Earth goes around, it's half. If we want 6 of Mars's orbits, how many orbits does Earth make around the sun? So 6 total orbits for Earth. Oh, I'm sorry, for Mars. And each of those, it takes 1/2 of Earth's orbits. So we would be dividing that. And that would give us 12 orbits for Earth. How many orbits does Earth make around the sun in the time it takes Mars to complete 6 orbits? For every 6, Mars has, for those 6, it takes Mars half. I can't word that. I hope you understand. My words don't want to work for that one today. All right. Kat uses a 1/2 gallon of water each day on a camping trip. Her water jug holds 5 gallons of water. How many days will Kat have water to use if she fills her water jug completely before leaving? We're going to draw a visual model and write a division equation. Excuse me. Thank you. All right. So she's using a 1/2 gallon of water each day. Her jug holds 5 gallons. How many days will she have water? So here are her 5 gallons. Not great with my boxes, but you understand. She's using 1/2 of that gallon each day. So we're going to divide those in half. How many days will she have water? How many parts do we have now? Well, we have 5 gallons that we divided by half, which would equal 10 days. I almost wrote gallons. I had to check the question. How many days? 10 days is what she will have for that water. Again, keep, change, flip. That's the action. We're dividing fractions. All right. Okay. Test prep. Are you ready? Again, just like always, if you want to pause here, if you haven't completed this, come back and check, see how you do. Darren has 10 pounds of carrots. He divides the carrots into 1/2 pound bags. How many bags of carrots does Darren make? 10 bags divided by half equals 20 bags of carrots. Select all the division expressions that have a quotient of 24. 4 divided by 6, keep, change, flip, that would be 24. 6 divided by 1/4, keep, change, flip, that would also be 24. 1/4 divided by 6, keep, change, flip, that would be 1/24. That's no good. 1/6 divided by 4, keep, change, flip, also 1/24. No good. 8 divided by 1/3, keep, change, flip, that equals 24. 1/3 divided by 8, keep, change, flip, that's 1/24. So we have A, B, and E. All right, number lines, not everybody's favorite. Let's see what happens here. We need to write an equation that represents the visual model. So I'm going to start off looking at what is my whole number. This goes from 0 to 3, so I think my whole number is going to be 3. What did those 3 get divided into? They're each divided into fifths. So we're going to take 3 divided by 1/5. Keep, change, flip. We should get 15. What does that quotient represent? Do you remember from class? That quotient represents how many spaces there are on our number line from 0 to 3. So let's see if there's 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's how we can check. Good. An 8-mile running path is divided into 1/4 mile sections for running sprints. How many sections for running sprints does the path have? Draw the model and solve the problem. It's an 8-mile path divided into 1/4 mile sections. So my equation or my expression looks like it would be 8 divided by 1/4. I'm going to do 8 models, 8 whole boxes or bar models quickly. And I'm dividing them into fourths each. Not perfect, but it gets the job done for our model drawing here. How many sections do they have? How many total sections do we have now if we took those 8 and we divided them by 1/4? We would have 32 sections. All right, how did you do? Are you ready for the test? Am I getting nodding, thumbs up? Okay, if not, bring those questions to class. Let's go over things, make sure you're ready. Draw a visual model to find 3/5 times 2/3. 3/5 times 2/3. How are we going to do this? Let's start off with our 3/5. If I have 3/5, I shouldn't have done that. 1, 2, 3, 4, 5. I'm gonna fix this a little bit. 1, 2, 3, 4, 5. That's a little more even. I'm dividing it by 2/3. So because I did fifths, 1, 2, 3, 4, 5, and I'm showing 3/5 this way. Do you remember this? 2/3. I'm going to go the other way. You might have some colored pencils nearby that you could use, but I'm going to show 2/3 all the way across. My answer then should be right here where those squiggly shaded in parts overlapped. So there are 6 out of how many total parts now? Should be 6/15 is what that model shows. That can be simplified, of course. I can check 3 times 2 is 6, 5 times 3 is 15. So that is one way to show that model. There are other ways. Did you do it the same way? Or if I start off showing 3/5, if each of these is 1/5, if I have 2/3 of those, how much do I have? 2/3 of 3/5. Could I do it that way? I could show it. I don't know that it exactly shows me the area like this one. I prefer the first one I did. And then find the product, 2/5 times 5/8. If I just multiply across, I would get 10/40. Now, I've talked in class that we need to start noticing simplifying when it can be done. If I have that 2 times 5, remember, I can change 8 times 5 in my denominator. And then right here, do you see? That's a whole number. So it's a 1. So now I would have 2 8s. If I think about that, I can rename that 8. 2 is my numerator. 8, I can rename that as 2 times 4. And I have found another whole number. So now I just have 1/4. And of course, 10/40 would simplify to 1/4. You also might just have noticed right here, those zeros, 0 zeros, that's a whole number right there. That's a 1. So there's the 1/4 as well. So try to start recognizing if you can simplify. While equivalent fractions are still correct, if you can simplify, I would just like you to start kind of paying attention to that. All right, so that's it for this lesson. We are getting close to the end of this module, so be sure, ask questions in class, make sure you understand, and I'll see you next time. Thanks for joining me.